McGill University once ran an experiment where students got paid to do absolutely nothing. No sound, no sight, no touch. Within hours, healthy adults started hallucinating. Within days, their brains stopped working normally on tests they'd aced the week before. This was 1951. The Cold War was heating up, and rumors were spreading that Chinese and Korean interrogators had figured out how to break a mind without laying a single hand on it. A psychologist named Donald Hebb wanted to know if that was actually possible, so he built a room to find out. The setup was almost insultingly simple. Healthy male college students lay on a comfortable bed in a small, softly lit cubicle. Their eyes were covered with translucent goggles, enough to let some light through, not enough to see shapes. Cardboard tubes were slid over their arms so they couldn't feel textures with their hands. A steady hum of air conditioner noise masked any outside sound. They could get up to eat and use the bathroom. That was it. No conversation, no stimulation, no task. The pay was generous for a college student in 1951, more than they could make anywhere else on campus just to lie there. Here's the thing, everyone who signed up thought it would be easy. Some even thought it sounded relaxing. A quiet room, no responsibilities, good money. What's the catch? The catch showed up faster than anyone expected. Within the first few hours, most subjects reported their minds starting to wander in ways they couldn't control. Not daydreaming, something stranger. Their thoughts became disorganized, drifting without any thread connecting one idea to the next. Some described a feeling of not being able to think in a straight line even when they tried. By day 2, it got worse. Subjects began seeing things, not vague shapes, detailed, structured visual hallucinations. One man reported watching a procession of squirrels marching across his field of vision, wearing tiny sacks over their shoulders, walking with what he described as clear purpose. Another felt his body split into 2 places at once, as if part of him were floating somewhere outside the cubicle while the rest of him stayed on the bed. And here's where it gets stranger. This wasn't just a few unstable outliers. The research team tested cognitive function before and after isolation, and the results were consistent across most subjects. People who scored well on reasoning and memory tests before going into the room came out measurably worse. Simple arithmetic that would normally take seconds started taking minutes. Subjects struggled to concentrate on anything for more than a few seconds at a time. Almost nobody made it through the full planned length of the study. One man chose to quit and go do hard manual labor for 1/3 of the pay rather than spend 1 more hour in that quiet room. Think about that. He gave up 2/3 of his money to escape total comfort and silence. Word got out. And when word gets out in science, other labs try to break it. A team at Princeton, led by a researcher named Jack Vernon, decided to see if they could reproduce what Hebb had found. What happened next tells you something nobody expected going in. Vernon's team ran the same basic setup, and at first, the hallucinations just didn't show up. A handful of subjects reported simple shapes and flickers of light. Nothing like the squirrels, nothing like the split bodies. The Princeton team started to wonder if McGill's results had been a fluke, or worse, an artifact of the specific room, the specific researchers, something nobody else could reliably produce. So they escalated. Longer sessions, stricter darkness, fewer breaks. And when they pushed the isolation further than Hebb ever had, the effect came roaring back, stronger than before. The lesson buried in that failure and recovery is almost more unsettling than the original finding. This wasn't a fragile one-off result from one strange lab. It was a dial. Turn up the deprivation, and the mind starts manufacturing its own reality on a predictable schedule, like a switch that will flip for anyone, given enough silence and enough time. Other researchers pushed the timeline even further. A psychologist named John Zubek, working out of the University of Manitoba, ran subjects through isolation not for hours or a couple of days, but up to a week at a stretch, monitoring their brain activity the entire time. What he found was that the deterioration wasn't a brief dip that leveled off. It kept going. EEG readings showed the brain's electrical rhythms slowing down the longer the isolation continued, the same kind of slowing you'd normally associate with drowsiness or the early stages of sleep, except these subjects were wide awake, lying in the dark, describing themselves as more disoriented by the hour, not less. So what was actually happening to these people? The leading theory Hebb and his team landed on was almost the opposite of what anyone expected walking in. We tend to think of the brain as something that just needs rest. Turn off the inputs, and the mind should relax, maybe even sharpen. But that's not what a healthy brain does when the world goes quiet. A healthy brain doesn't shut down. It starts manufacturing its own reality to replace the one that's missing. Your brain, it turns out, isn't built to process nothing. It's built to constantly process something. Sound, light, texture, movement, an endless stream of raw material it uses to build your sense of where you are and who you are. Take that material away, and the machinery doesn't switch off. It starts running without fuel, and what comes out the other end is noise the brain mistakes for signal. Hallucinations aren't a malfunction so much as a factory with no raw materials left, still trying to produce something on the line. And this is where the research took a darker turn than anyone in that first lab expected, because Hebb's studies weren't happening in a vacuum. His work was funded by Canada's Defence Research Board, and the isolation techniques his team documented were later folded into interrogation methods used through the Cold War, deliberately weaponizing exactly the vulnerability his experiments had uncovered. What started as an inquiry into attention spans on long, boring military watches became a blueprint for breaking a person down using nothing but silence and time. No physical contact required. That should tell you something about how seriously the effect was taken. Nobody funds interrogation research based on a mild inconvenience. They fund it because taking away a person's sensory world was found to be one of the most destabilizing things you could do to a human mind. More effective in some cases than physical coercion, and far harder to see coming from the outside. So why does total silence do this to us? When we spend so much of our lives complaining we don't get enough of it. Because your brain evolved in an environment that was never actually silent. For hundreds of thousands of years, the ambient hum of the world, wind, insects, distant voices, footsteps, rustling grass, was constant background information your nervous system used to stay oriented, to know it was safe, to know where threats might be coming from. Silence, real total silence, almost never occurred in nature. When it did, it usually meant something had gone wrong. Predators go quiet before they strike. Prey goes quiet when it senses danger. A sudden absence of sound was itself a signal, and an unrelenting one was something your ancestors' brains had almost no reference point for. You weren't built for a world with a mute button. You were built for a world that never stopped talking to you in the background. And when that background disappears completely, your brain doesn't experience peace. It experiences an absence it doesn't know how to interpret, and it starts filling the gap with whatever it can generate on its own. Squirrels in sacks, a body split into two places, brainwaves slowing toward sleep in a person who is still, technically, wide awake. We treat silence like a reward, something to chase after a loud day, a loud year, a loud life. But what those subjects found out, some of them within a matter of hours, and others only after researchers deliberately pushed the isolation further and further to see where the breaking point actually was, is that the mind doesn't actually want the noise gone. It wants the noise managed. It wants just enough information coming in to keep building the world it needs to feel like itself. Which means the quiet you think you're craving right now isn't really quiet you want. It's relief from the specific noise you're dealing with. Total silence was never the goal. It was never even survivable for very long. Not for the healthy young men who volunteered for a few extra dollars in 1951. Not for the subjects Vernon pushed further at Princeton. Not for the ones Zubek kept in the dark for a week at a time. And probably not for you either. The room is still there conceptually, waiting for anyone who thinks they'd handle it differently. Most people who say that have never actually sat in it.